All right, ladies and gentlemen, Mr. Brescher here. Today we're going to focus on dividing rational numbers, part 2. Our objective is that we'll all be able to accurately divide with rational numbers, and this particular lesson is going to focus on dividing with integers as well as positive and negative fractions and mixed numbers. If you're interested in positive and negative decimals, you might refer to the video on dividing rational numbers, part 1. Let's move on and check out some rules. So we're going to use an understanding of fact families to help make connections between multiplication and division of integers. If you watched the part 1, you can skip this part because it's very similar. First of all, if we go way back to 2nd grade and recall that 3 groups of 2 is equal to 6, or 3 times 2 equals 6, then we know when we divide with these numbers, we can take the product 6 divided by one of the factors, and our quotient will end up being the other factor. So 6 divided by 3 is equal to 2. We could also take that product 6 and divide it by the second factor, and we get the first factor. So 6 divided by 2 is 3. Now, if we connect this with an understanding of multiplication of positive and negative numbers, like this example, 3 groups of -3 equals -9, or you could say -3 plus -3 plus -3 equals -9. Then we could take the product again, -9, divided by one of the factors, and we should get the other factor as our answer, or we will get the other factor. We could also take that product -9 and divide by the second factor to get the first factor. And our answer, -9 divided by -3 equals a +3. So back in 2nd grade, we learned that a positive divided by a positive is equal to a positive. Now we learn that a negative divided by a positive equals a negative, and a negative divided by a negative equals a positive. So what happens when we have a negative or a positive divided by a negative? Well, if we use this multiplication problem, and again, if you can't remember that a negative times a negative equals a positive, and you want to see the pattern and how we prove that this must be true, go back and check out the multiplying rational numbers part 1 or part 2. But -3 times -3 equals +9. So again, if we took the product 9 and divided by one of the factors, we will get the other. So we know a positive divided by a negative is going to give us a negative using this understanding of fact families. Now, the goal was to divide with positive and negative fractions and mixed numbers, but first we need to be able to divide with just positive fractions and mixed numbers. So let's review a few key things to use when dividing fractions and mixed numbers. First of all, we want to use keep, change, flip, or we could say multiply by the reciprocal, also called the multiplicative inverse. So we're going to keep the first fraction the same, change the division sign to multiplication, and the second number is going to become the reciprocal. That's where the numerator and denominator switch places. Now, the next thing we want to do is cross-cancel if possible. In this case, there's a common factor in the numerator and denominator, and that is 2. 4 divided by 2 equals 2. And 2 divided by 2 equals 1. Now, since there aren't any more common factors besides 1, we're going to multiply across. 3 times 1 is 3, 2 times 1 is 2, and we get our answer of 3/2. The last step is just to simplify. This is an improper fraction, so when we simplify, 3 divided by 2 equals 1 1/2. Now, there's only one additional step when you're dividing with mixed numbers, and that is to convert the mixed number into an improper fraction. So we're going to take 3 times 4 So multiply the whole number by the denominator and then add the numerator. So 12 plus 3 is 15. And we're going to rewrite this problem as 15/4 right here. And we're going to do the same thing for 2 and 2/5. So 2 times 5 is 10, plus 2 is 12/5. Notice I did not change the division sign. If you try to do too many steps at once, that's where you will make mistakes. So unless you've been working with these types of problems for a long time, I recommend doing one step at a time. Now we're ready to use keep, change, flip, where we keep the first fraction the same, change division to multiplication, and we change 12/5 into its reciprocal or multiplicative inverse. So notice the numerator and denominator switch when we move to this step. So we're multiplying by the reciprocal. Look for cross canceling. In this case, there's a common factor of a 3 that goes into both 12 and 15. Notice we can only cross cancel with the numerator and denominator, not between two denominators. 12 divided by 3 is 4, and 15 divided by 3 is 5. There are no other common factors. Just because 4 and 4 are the same, they're both in the denominator. In order to cross cancel, one has to be in the denominator and one must be in the numerator. So we multiply across. 5 times 5 is 25, and 4 times 4 is 16. Now we need to convert this improper fraction back into a mixed number. 25 divided by 16 equals 1 9/16. So with the same problems, now we're going to add negatives in front of some of our divisor and dividend and see if we can apply the rules for dividing with negatives. A negative 3/4 divided by negative 1/2. Yeah, it's still going to equal a positive 1 1/2. So we get the same answer. We just have to think about how the negatives affect our quotient. Now our dividend is actually a negative and our divisor is a positive. A negative divided by a positive, yeah, it's going to give us a negative. So we're going to still get 1 9/16, but it's a negative 1 9/16. All right, now it's your turn. We're going to practice here a little bit. So take out your paper and pencil and get ready to practice with these problems. Pause the screen and see what you get for 2 1/4 divided by negative 3/8. Okay, let's see what you got. Did you convert to an improper fraction and then multiply by the reciprocal? Did you remember to cross cancel in this case? We can factor a 3 out of both of these values, and we can factor a 4 out of both of these values. Then all you have to do is multiply across, but remember, a positive times a negative equals a negative. Our answer is negative 6. Let's try this one, negative 1/4 divided by negative 1/8. Pause the screen, and then we'll go over it. Okay, let's check it out. First of all, a negative divided by a negative, you should have gotten a positive answer. If we rewrite it with the reciprocal, we actually have a common factor of 4 that goes into both of these values. 4 divided by 4 is 1, and 8 divided by 4 is 2. A negative times a negative is a positive, and when we multiply across, we get a positive 2 as our answer. Let's do the next one, negative 5/6 divided by negative 1/2. Pause the screen, work it out, and we'll check and see how you did. All right, a negative divided by a negative is a positive, so we should get a positive answer. And we can factor a 2 out of both of these values. Remember, you always want your answer to be in simplest form also. When we multiply across, we get 5/3, which is an improper fraction, so we need to simplify. 5 divided by 3 is equal to 1 2/3. Let's try the next one, 3/8 divided by negative 3/5. Pause the screen, Work it out. Let's see how you did. You should have written 3/8 times negative 5/3. Notice we're multiplying by the reciprocal. If we cross cancel, the common factor is 3 between these two values. When we divide them both by 3, we're left with 1, and now we're ready to multiply numerators 1 times 5 and denominators 8 times 1 to get our answer. A positive times a negative equals a negative 5/8 as our answer. We're almost done, just a couple more to go. Go ahead and solve 7 1/2 divided by negative 2 1/2. All right, 7 1/2 divided by negative 2 1/2. Let's see how you did. 7 1/2 divided by negative 2 1/2. A positive divided by a negative. And we get our answer, negative 3. Moving on. The last problem, a negative 2 1/2 divided by 5/8. Again, pause the screen, work it out. Let's see how you did. All right. And if you take negative 2 1/2 divided by 5/8, we should have a negative quotient. And the answer is negative 4. So I hope that helped you to understand how to divide rational numbers, specifically positive and negative fractions and mixed numbers. See ya.